Hello everyone, and this is a very brief look at MOPs, which are essentially motion operators for Houdini. So the first thing is they're free. Okay, so you can just come to motionoperators.com and download it and install it. It'll work on any version beyond, I think, 16.5. So beyond Houdini 16.5, you can install it in any version that you want. So first of all, what exactly is MOPs? So MOPs is primarily like a motion graphics tool set. But what I want to do with this particular video is we're not going to look at the entire tool set. What I want to do is I want to show you how to use MOPs as a complete replacement for the standard copy tools that are available in Houdini. So if you look at the basic copy to points tool, okay, it's really sort of bare bones, right? Like you just have these options for copying attributes, but beyond that, there is almost like nothing else you can do here. Okay, like if you want to randomize points, you want to randomize scaling, rotation, whatever, you need external tools, right? You need to apply like a randomize or an attribute noise, or you want to, you'll have to type in some code if you want to do something more complicated. If you want to have like multiple objects randomly scattered, you need to generate a piece attribute, then you need to do stuff for that. So with MOPs, it takes a lot of those things and just makes it very, very simple. So which is why the primary target of this particular lesson is just to show you how you can use MOPs as your standard copy tool in Houdini. Okay, so to start off with, what I have in my scene is I have this one grid, okay, and then I made like this simple sort of flower like thing. So I have three of them. So I have a sphere and a box. So I had the box and the sphere, and I have this, pyramid. Okay, so we're eventually going to copy onto the grid, but to start off with, we'll just sort of copy one of these. And the way to do it is once you've installed MOPs, which you will get the procedure here. Like if you come into this, you'll get all the documentation and how to install and everything. Like it's not complicated. Okay. So to start with, if you press tab, you will get a menu called MOPs. And within that, if you come to generators, you'll find MOPs instancer. Okay. So the MOPs instancer is what you want. So primarily what it's doing is it's internally converting everything to packed primitives and then modifying those. But even if you don't understand any of it, it's fine. Like it's all being done in the background. You don't need to, sort of understand any of this. Okay, so the way it works is if you connect one of these in here, like on top, it'll just copy them in a grid. So it has, the first really good thing is in the distribution section, it has like a whole bunch of ready-made patterns. So you can do linear, you can define number of points, and you can define like the length of it. And then you can have radial. So again, you can define the scale of that. You can define the number of points again. So you have a whole bunch of stuff that is inbuilt directly. Like you don't need to worry, but you have spherical, you have grid. Okay, so with grid, you can define the size in X, Y, and Z. So it'll also make like a three-dimensional, grid. And the step size is the distance between the copies. Okay, so if you just want to have like a large enough grid, you can just do that. And then you can also have like a honeycomb pattern, which is nice. So if I just increase this and, let me just sort of increase that as well. Yeah, see, so there you go. So you can do a basic honeycomb pattern. And then you can either have a curve or a mesh. Okay, so we'll take a look at those a little later. Now, along with this, the other option that is really nice is you can automatically just take multiple objects. So you don't need to do any of that variant attribute or anything like that. Like if I just plug in these three, it'll automatically randomize between them. So as many as you take, it'll just randomize. So you don't need to worry about it. Now, the other great thing in here is if you come to the instancing tab, it gives you the ability to control the size of your copies. Okay, so you have two options. You have the global transform where you can sort of, globally control everything. So which is not bad. Or if you come down here, then on a per object basis, it gives you control. So if I just want to control like this particular flower, then I can just open that up and just control that. So you get individual controls and you get global controls. So which is really nice. Then you have options for like basic display. So you can display it as a point cloud or something, but yeah, let's just keep it to full geometry. And then you can randomize it. You also have other options, which is you can have it random. Okay, the scattering of the objects. You can have it ordered, so they will go in like this. Or if you take in a mesh, then you also have an option to generate an attribute on the mesh and then it will scatter based on that. Okay, so I'll show you that when we get the mesh. Okay, so the point being, just from the get-go, this is way better than taking the copy stamp or taking the copy to points, because the copy to points has no controls. Okay, so any of this stuff you had to do with copy to points would have required a lot more steps by now. Okay, now how do you take a mesh? Because there is no mesh input option over here. So what you need to do is you come into distribution and you take mesh, and then what I'll do is with the grid over here, I'll just I'll create a null at the end of it. I'll call it outsource, and we will just drop it in there. Okay, so just take this and drag and drop it in here, and there you go. Okay, now when it copies to this, it takes the Z as the up axis, so everything rotates. So what you want to do is you want to come back to instancing global transform and rotate it to 90. So then it will sort of, stand upright. Okay, so here again, it gives you some really nice options. So the default it goes to is scattering, but you can scatter to points. So it will go to individual points. Let me just, yeah, so there you go. So you can see that it's on every point. You can also do primitive centers, which is great. Like, again, doing primitive centers has always been a problem. Like you need to take a divide and turn it into a dual mesh, and then the points that you get, those are the primitive centers. But again, like it's multiple steps, which is just inbuilt over here. You can do edge centers, so it will go to the center of every edge. So again, like those things are nice. And you can also do voxel. Okay, but yeah, I don't really need to do that. Okay, so the basic confession is I don't know too much of MOPS. Like I started using it 3 days ago. Okay, even though MOPS is pretty old, I'm kind of late to the party. But I started to use it and immediately realized like this is the replacement for copy to points that I've been looking for. So I immediately said, okay, I'm making a video at least for that much, because anybody who's using Houdini, you should definitely use MOPS. Okay, so let's come to primitive centers. Okay, and then we will just modify the grid a little so I can show you a few more options in there. Okay, so let's increase the number of points. So you'll see that it automatically just increases, and I will reduce the size over here. So I'll just come down and just make it small. Okay, now what I want to do is I want to create a noise map and then convert that noise map into an index value. So what it needs, if you look here in the instancing option, it has indexing mode, and then we saw random and ordered. But if you change it to point attributes, it looks for an index attribute called mops underscore index. So based on this value, you can distribute the objects that you have. So what I can do is I can come in here and I'll just take an attribute noise and we'll keep it to 1D. So we basically have something that looks like this. We're going to remap it and lower the roughness, increase the element size, and I'll just call it mops underscore index. Now, this is currently a float value, so it actually needs to be converted to an integer for the instancer to understand it. Okay, so what you need to do is, again, the great thing is that they've thought of all of this, so you get tools for this. You don't need to go type in any code. Okay, so if you come into mops and you come into tools, you will find something called index from attribute. Okay, so click on index from attribute and drop it in there. and it's going to pick up MOPS. So by default, it looks for MOPS fall off, okay, which is like the fall off attribute, but we want to pick up MOPS index. And that's pretty much it. Like if you want to visualize this, what I can do is I can take a color node and you should be able to visualize it, because I can just come in here and say RAM from attribute and pick up MOPS index, and see, there you go. So it's generating 3 values. So let's take this to 2. See, there you go. So what it's done is it's generated like these bands. Okay, so this is 0, 1 and 2. Okay, so that is what it has generated. And based on this, it can do scattering. So if we go back to our MOPS instancer, you'll immediately see the difference. See, there you go. So based on that noise map, it automatically took care of scattering. And if I animate the noise map, if I turn it on, if I switch on animated, you'll actually get it animated. So again, the great thing to think of right now is I haven't written any code as yet. Okay, like all of this is just inbuilt. The other really nice thing that comes in here is if I apply like a mountain to this. Okay, so if I just take a mountain and drop it in, it will automatically align to the normals. Okay, so that sort of comes in inbuilt. And the reason why that is important is one of the issues that I've always sort of faced with copy to points is that if I want to rotate along normal, that is always tricky. Okay, like you do need to write in some code for that. Okay, because there's no inbuilt option to do rotate along normal. But anyway, so if once we applied the mountain, it will automatically align to, you know, whatever the grid is supposed, whatever the normals are supposed to be. Now, along with this, you can also do something interesting, which is, so if I take the same noise attribute that I've generated, this MOPS index, and I put it into density, okay, then I can also control the scattering based on that. So if I just take a wrangle here and I will generate a float attribute called density, which will be equal to at MOPS underscore index. So you do this before you convert it into an integer, because this guy will convert it to an integer. Okay, like that's an integer value now. So you should do it before, you know, before all of that happens. Okay, so now if you come back here and if I change this distribution type to scatter, okay, and if you come down to the options, you will find the scattering options, and we can increase the number of points. And then I can just turn on the density attribute, and there you go. See, so it's basically controlling it now based on that particular noise map. Okay, so if I just come back here and if I was to adjust this, see, so you can actually, like, you know, and what you can also do is if you want to adjust the scattering, I can come back to the MOPS index and you can adjust the attribute range. So if I start to increase this, see, and if I start to increase that, you can kind of control, you know, how much you want. Okay, now let's come over to the more interesting stuff, which is what if you want to randomize the rotation or the scale or even the position? Okay, so I'm going to take this back to primitive centers, or points would be fine. Yeah, points is okay. And I'm going to lower, or let me just increase the element size here. Yeah, okay. I think this is fine. So what if you want to randomly rotate them? Okay, this is where things become interesting. So if you come into MOPS and you come into modifiers, you will find a bunch of them. And the one that we want to look for is called MOPS randomize. Okay, so you just take a MOPS randomize and plug it after the MOPS instancer, and it gives you some really nice options. Now by default, it's looking for a fall off because you can generate fall offs, but we don't want a fall off. We just want to, you know, randomly control everything. So I can just turn off the fall off. And then let's say I want to randomize the uniform scale. So just turn that on and there you go. You can randomize the uniform scale. So you don't need to generate a p-scale attribute or anything like that. Just, you know, sort of you can randomize this. Now let's say I want to randomize the rotation as well. So I can just come into randomize orientation. So by default, it'll randomize everything. So just, we'll make everything 0 except for Y. See, there you go. Okay. And you also have like a seed value, so you can modify that. Okay, you can also blend it. So if you want to animate this, you could also animate this. Okay, but if you just want to like blend a little bit of it and decide like, you know, it shouldn't rotate all the way around, maybe just a little bit. So you can do that. Like if I come into this point and turn it into a scatter, so we have a lot of points, you know, so you can just, you know, let's see how many points we can get. Because it's packed primitives, you can actually throw in like a lot of geometry in here. And maybe we can just lower the size a little. Yeah, so here, this is where it becomes interesting, is that if you want to now control this using a fall off or something, you can do those things. So you can take something, if you type in shape, then you'll get something called as MOPS shape fall off. So I can plug that in before the randomize. And by default, it generates like a linear fall off, which you can preview. So if I want, I can turn on preview fall off. See, so this is the fall off that we have. And I can just adjust the scale of this. And you have different types in this, but I won't go into anything too deep. So if I just take the linear and let's say if I make it spherical, okay, or no, let's keep it linear, it's fine. And then if I come back to, I'll turn off preview fall off. If I come back to my MOPS randomize, okay, now you're seeing these grid patterns because my geometry count is very low. So that's why you're getting the grid pattern. So let's make this about 200 by 200. Yeah, see, so then it's smooth. Okay, so I can just come into the randomize. And so right now it's randomizing everything. If I change it, if I turn on enable fall off, see, so now it's only randomizing that side. Okay. And then I can animate this or move it around if I want to. So if I just take this and I move it, see. So you can sort of like, if you want to just locally randomize, you can even do that. Or now you can do other things like if I take in a transform modifier. Okay, so if you type in transform, you'll find something called MOPS transform modifier. Okay, so if I plug that in the middle, and then let's say I want like that side to be small. Okay, so I can again, like it by default uses fall off. If I just lower the uniform scale, see. So now that side is small and then I can just control it. I can even move it around, but I don't want to do that. Okay, so I can just take the MOPS fall off and like, you know, move it. See, so you can actually just, you know, animate this if you want to. But the point being that, you know, all of that complex stuff that you were doing earlier, because even doing this, you would need like a mask from geometry and then create an attribute and then copy that into P-scale and, you know, blah, 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 a whole bunch of stuff. This is just, all of it is ready-made for you. Okay. What you can also do is as a final thing, like if you don't want this, you can also just use like a noise modifier. Okay, so you get a MOPS noise fall off. So if you come into fall off, you'll find something called MOPS noise fall off. And what the noise fall off does is it just generates like a noise map. Okay, so you can just come in here, and if I was to, you know, lower the frequency of this, and I can take the transform, make it really tiny, or make it big. No, hold on. Yeah, make it really tiny. And I can come into the noise, and maybe we can also come into remap. Okay, and we'll just sort of remap this. Yeah, see. So we can actually just, you know, yeah, control it that way. And you can also just, let's just give it some offset. Yeah, there we go. So now, so this is primarily it. Okay, so I won't go too deep into it because honestly, I don't know all of it. But as I said, like what it is at a very basic level is an excellent replacement for, you know, all of the copy tools that you were using and all of the various combinations that you had to do. You can just use like the basic MOPS instancer and randomize, and even that itself gives you like an n number of things that you can do, which earlier you required like a lot of vex and a lot of nodes to do. Okay, this is all just inbuilt and you don't have to write a single line of code or anything, and it just works. Yeah, so this is essentially it. So this is a very, very brief look at MOPS. And my plan is to try and replace my entire old MoGraph series and recreate that entirely with MOPS. Yeah, so as usual, if you have any questions regarding this or anything in general about Houdini, you can ask me in the comment section, or you can write to me on Twitter or send me an email. Usually I answer, sometimes I get lazy. Usually I try to answer. Okay, if I know, I'll definitely answer. Again, like as far as MOPS is concerned, I'm at, like, my knowledge is very basic level. So you can also go to their website and they have a forum. You can also ask questions over there. That is also a perfectly logical thing to do. But yeah, if I can, I'll definitely try and answer your questions. Yeah, so once again, I hope this was useful, and that's basically it.